Hello, my name is Edward Wustenhoff. I am CTO and co-founder of Burstorm. And in this segment I'm going to introduce you to some terms and concepts that are unique and important in the Burstorm application. So before we dive into the details, let me explain to you what the Burstorm application is designed for. And at its core, we're just trying to enable the cloud ecosystem, both from a product manager's perspective, giving them tools to manage their products in the context of compute and storage, data center, and network, and describing the aspects of economics, performance, security, availability, and change. And on the other end, we're enabling the architects to collaborate and design using a common specification language, new and existing cloud architectures. So how does this manifest itself in the application? Well, what you see here is the landing page, and on the landing page you see the big components in the application. The first on the left is the dashboard. The dashboard basically gives you a current state view. Next to it is a design, and in the design area you can model and remodel existing infrastructures and see what certain design decisions have for an impact. In the quotes is designed basically to bring together what we would refer to as build specifications, which are very specific with product names and very specific costs and things that can really be delivered, and bring them together with designs that request less specific, so basically bring the build specifications into a model. Then we have the products area. This is where product managers can manage their products, and architects can browse product sets. The performance area is where we have all the performance benchmark information available with the standard graphics and views to do deeper analysis. Then last but not least is research, where we have the capability to do some generic searches of services available at certain locations, etc., etc. The dashboard captures information in what we call blueprints. Blueprints is an organized group of contract-like information which includes products, prices, locality, business terms, and like early termination fees, etc., etc., and creates a visualization of all that information. Once this information is entered, we create what we call a financial benchmark. The financial benchmark creates an ordered list of all the blueprints and its associated contracts, and gives some basic information with the time to action associated with it. So you get an ordered list of things that might need attention. The simplest example is if you entered a contract expiration date, that it will alert you that this contract is going to expire soon. Or more complex, we can capture not only the contract costs to date, but also capture a market estimate, and based on the cost to exit, it can alert you that, well, you might have a break-even point within a certain amount of time, and you might want to take a look at that. That is what we call the financial benchmark. This all then comes together in the dashboard of the dashboard. This is an overview page where you can see cost over time and how it is distributed between compute, storage, data center, and networking costs. It gives a overview of totals of how many servers, how much storage, how much power, etc., etc. What the total spend is in the last month, and any potential savings. If you went in and you created market estimates, it will map that against the cost to exit that is known, and it will show you a set of potential savings over time. All this together is what we refer to as the dashboard. Information from existing blueprints can easily be copied to its equivalent called a model. This is an area where we can run what-if scenarios, change the contents, change the locations, and can run all kinds of what-if scenarios. Within a model, we have design scenarios, and you can run recommendations against design scenarios. The model is designed to help run larger context optimizations, like what you can see here. We can obviously optimize for the fewest cost, where it would look at all the options for all the design scenarios and pick the lowest cost provider solution for that. Or you can optimize for the fewest number of providers. You can see if you have a complex design like this, you could end up with 20 different suppliers. Another optimization is then to pick, well, here are the fewest number of suppliers that can deliver this the most cost effective. That is the purpose of the model. Each model contains one or more design scenarios, what you see here. And the design scenario is a group of objects, whether it be compute, storage, data center, or network components, and they are coherent and adhering to the same or similar set of requirements, meaning these would all be in the same location, or these would all have to adhere to the same business model, meaning I want to sign up for this for 1 month or for 3 years, and I want to pay upfront for it or not. They adhere to the same compliance requirements, etc., etc. So it's a logically grouped set of compute and storage, data center, and or network components. It's up to the architect to determine what is the best logical grouping of these things. Once they are in a design scenario and defined as such, we can show different results. And you can see here is a nice graphical representation of all the solutions and where they would end up based on the locality requirements, which like here looks like it's around 2,500 miles around Dallas or so. Once it is in, we can start looking at options. So once the design scenario is completed, you can ask for recommendations. And what we refer to as the recommender is a system that searches all the potential product sets for solutions for each object, and then selects the most and best matching or better solution for this. So it will always try to find the closest capability to deliver a particular component. It then organizes it in a logical order, so you can see which products were selected for what. It will show you things like how the different product sets and solution providers compare in the context of cost, and very shortly also in the context of performance, so you can get a price performance comparison, etc., etc. So all that logic, all the complexities around comparing apples to apples, with the ability to include your own cost on top of this, is captured in what we call the recommender engine. And the recommender engine is executed against design scenarios, and design scenarios find themselves in a model that represents a larger problem that may consist of one or more design scenarios, and enables us to optimize beyond just single product sets. So the other big component in the application is what we refer to as quotes. This is really an area where we allow build specifications to be connected to models and designs. So where a design is there to model options, a build scenario is there to help transition into deployment. What we notice is that solution providers often provide build specifications in the context of a quote in order to help architects ascertain the economic impact of a certain design approach. They request a quote. To facilitate that process, we created what we call the quotes area, where the product managers and the provider representatives can create basically a design with their solution sets in mind, so very specific to their particular capability to deliver, and attach that to a more generic design from the enterprise architect that requested a particular solution, not knowing what options the provider might have. So what you see here on the right hand side is the original request of the design in blue, and on the left the consolidation pattern build, where they actually, the provider suggested, why don't you consolidate some of these components, these two Linux boxes, in what is here represented as other systems, the square box somewhat in the middle. In addition, we're also working, this is a roadmap item, on enabling the transition of build specifications into run specification that will be able to attach to deployment systems. So whatever was modeled and designed can be quoted and bought and then actually be deployed all through the same system. In the next big set, which we call products, we provide the tools for the product managers to manage their product sets and benchmark them against the market. And the way we do that is we structure product sets in solution sets. So this allows product management to segment out, for example, compute from storage, from data center, and have different people manage those particular products and roll them up into a solution set that is being used in the recommender that I mentioned earlier to map and match against design objectives. The other side in the product area is what we call the benchmarking capability, where we provided what we call the market insights benchmark with common design approaches that we see in the app. And the product manager can immediately see how their products map and match, so they can look at the detail which product of mine maps against this common design requirement, and also against publicly available pricing structures, so they also get an idea as to where from an economic impact they sit. So within the products area, we allow the product managers to manage their product sets in the context of information from design perspectives, but also from the market. So the last big part in the application is what we call the performance area, where we do display the performance data that we have collected. I have a separate video about the performance benchmarking, but in essence at Burstorm we measure every instance all the time, everywhere, meaning on a regular basis we run performance tests on different times of the day, on different days of the week, again for all instances of the top service providers and a couple of more, and that number is growing, and reflect that data in here. So what you see here is an example of performance of 4 core systems versus the price performance of those same systems, and you can see things change depending on whether you only care about performance, at which time this system here on the far right, which is I believe an AWS system, or if you can split out that same workload over multiple systems, then you might actually consider going for the little line notes box here and spread it out over multiple systems, because the cost per performance tick is much cheaper on those Linode systems than on the AWS system. So in the performance areas we have performance over time, we have performance by location, we have performance by split out over what chipsets and architectures are being used. So many different interesting aspects, and very soon you'll be able to include your own enterprise solutions if you run the performance benchmark tests on it, include that data in this view, and now you can compare your own systems in context of what we know about the market and where it's going. So in summary, I've talked to you about all the major components in the Burstorm application that help enable the cloud ecosystem. We talked about the dashboard for the current state. We talked about the design area where you can model new the infrastructures or remodel existing ones. I talked about the quoting capability where we attach build specifications to the model, so you can include more specific information into your modeling, and it's also a jump-off point to our ability that will soon be there around being able to spin up a originally designed infrastructure. Then there was the products area where we enable product managers to manage their products in context of the market and give them data, and also in context of the designs that we see are common in this particular market. And lastly, I talked a little bit more about the performance data that we have in the app that allows architects to see how certain instances compare to each other based on time. We've seen many shifts there, locality, and even what it is built on. The last part I've not talked about. It's basically a research area where you can do basic searches on particular product sets in different locations. A very straightforward component. Thank you for watching this video. I hope you enjoyed it as much as I did making it. If you want more information, please go to www.burstorm.com where there'll be more videos and other materials for you to read. Or you can send us an email at info@burstorm.com or call us at the number on your screen. Thank you.